The electrical conduit serves as a protective pathway for electrical wiring, shielding it from physical damage, moisture, and other environmental factors. Selecting the appropriate type of conduit is crucial for ensuring the safety and longevity of an electrical system. The selection of conduit depends on factors such as the location, environment, and the type of wiring it will protect. Three common types of electrical conduit are PVC conduit, EMT conduit, and rigid conduit. PVC conduit, or polyvinyl chloride conduit, is a popular choice due to its cost-effectiveness, ease of installation, and resistance to corrosion. It's lightweight and can be easily cut, enjoying using PVC cement. Its non-conductive nature makes it a safe option as it doesn't pose an electrical shock hazard. However, PVC conduit is less durable than metal conduits and can become brittle, especially in cold temperatures. It's also not suitable for use in areas where it will be exposed to high temperatures or physical impact. PVC conduit is often used in residential applications, underground wiring, and in corrosive environments. EMT conduit, or electrical metallic tubing, is a type of thin-walled steel conduit, often galvanized for corrosion protection. It's more durable than PVC conduit and provides better protection against physical damage. EMT conduit is lighter and easier to bend than rigid metal conduit, making it a versatile choice for many applications. It is joined using fittings that are either compression type or set screw type, creating a secure and grounded electrical raceway. EMT conduit is commonly used in commercial and industrial buildings for exposed or concealed wiring. However, it's not recommended for direct burial unless specifically listed for that purpose. Rigid conduit, also known as rigid metal conduit or RMC, is the thickest and most durable type of electrical conduit. It's made of galvanized steel or aluminum, providing excellent protection against physical damage, corrosion, and electromagnetic interference. Rigid conduit is typically used in harsh environments such as industrial plants, chemical facilities, and areas where wiring is exposed to severe mechanical stress. It's also suitable for direct burial and can be used to support heavy electrical equipment. Due to its thickness and weight, rigid conduit is more difficult to cut, bend, and install than PVC or EMT conduit. It requires specialized tools and techniques for proper installation. The National Electrical Code, or NEC, provides guidelines for the use of different types of electrical conduit in various applications. NEC Section 300.12 addresses mechanical continuity of raceways and cables. Raceways, including conduits, must be installed as a complete system and be mechanically continuous between enclosures. This is to ensure proper grounding and to provide a continuous path for fault current. NEC Section 300.15 covers the requirements for raceway fittings. Fittings must be identified for the specific type of raceway being used and must be installed in accordance with the manufacturer's instructions. NEC Section 310.16 provides ampacity tables for conductors. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. The type of conduit used can affect the ampacity of conductors, as enclosed conductors can generate heat. NEC Chapter 9 contains tables and examples for conduit fill. The fill rate dictates how many conductors can be placed inside a conduit. Conduit fill is the percentage of the cross-sectional area of the conduit that is occupied by conductors. The NEC specifies maximum conduit fill rates to prevent overheating and to allow for easy wire pulling. The choice of conduit material can also impact the grounding and bonding requirements of an electrical system. Metal conduits, such as EMT and rigid conduit, can serve as equipment grounding conductors if they are properly installed and connected. PVC conduit, being non-conductive, requires a separate equipment grounding conductor to be installed within the conduit. When installing electrical conduit, it's important to follow all applicable codes and standards, including the NEC and local building codes. Proper installation techniques are essential for ensuring the safety and reliability of the electrical system. Firstly, planning the conduit run is essential, and it involves determining the path the conduit will take, taking into account any obstacles or obstructions. Secondly, measuring and cutting the conduit to the correct length, Using appropriate tools such as a conduit cutter or hacksaw is also important. Thirdly, bending the conduit to the desired angles using a conduit bender is required for directional runs. Fourthly, reaming the cut ends of the conduit to remove any sharp edges or burrs helps prevent damage to the conductors. Fifthly, assembling the conduit sections using appropriate fittings such as couplings, connectors, and elbows to create a continuous raceway. Sixthly, securing the conduit to walls, ceilings, or other structures using conduit clamps or hangers is necessary for support. Seventhly, pulling the conductors through the conduit using a fish tape or wire pulling lubricant minimizes friction and prevents damage to the insulation. Eighthly, connecting the conduit to electrical boxes or enclosures using appropriate connectors ensures a secure and grounded connection. Ninthly, grounding the metal conduit system by bonding it to the grounding electrode system provides a path for fault current. Tenthly, inspecting the completed conduit installation to ensure that it meets all applicable codes and standards is critical for safety and compliance. In addition to the three main types of electrical conduit, there are also several specialty conduits available for specific applications. Flexible metal conduit, or FMC, is a flexible conduit that is used for short runs in dry locations. Liquid-tight flexible metal conduit, or LFMC, is a flexible conduit that is used in wet locations. Electrical non-metallic tubing, or END, is a flexible non-metallic conduit that is used in walls, floors, and ceilings. Each of these conduit types has unique properties and applications. Proper selection and installation of electrical conduit are essential for ensuring the safety and reliability of electrical systems. Consulting with a qualified electrician is recommended to determine the best type of conduit for a particular application. The long-term reliability and safety of electrical systems depend on the correct choice and installation of conduit. Factors like environmental conditions, potential for physical damage, and applicable codes should guide the selection process. By understanding the properties and applications of PVC EMT and rigid conduit, one can make informed decisions that contribute to the overall performance and safety of electrical installations. It's crucial to stay updated on the latest electrical codes and best practices to ensure compliance and prevent potential hazards.